Hello, everyone. I hope everyone can see the PowerPoint that I had. I'm sorry if it's put together a little sloppy, but I put it together as best as I could, and I'll explain as best as I can with everything that I have here. So the first part goes over complex numbers. This will be with polynomials and rational functions. One of the complex numbers that we have here is the imaginary unit of I. I is used as an imaginary number. It is used, as you can see, for representing the square root of -1. And that is where we would use for in the equations that we use for complex numbers. So you have a square root of -1. You can also have the square of the square root of -1. So that would make it -1. So this is a concept that they use for x squared. The next part is a complex of numbers a plus b times I. So this works under the numbers that we have of real numbers and imaginary numbers. With the real numbers, b is equal to 0, and whereas the imaginary numbers, we have b not equal to 0. So as you continue on with your studies, this is what happens. And you come into a problem where they use imaginary units or complex numbers. Some of them have some rules and some things that you can work on. A plus b times I plus c plus d times I is the addition rule for complex numbers, where you can rewrite it as a plus c is equal plus b plus d times I. And as you can see, for the subtraction, it follows a similar rule for when you're subtracting, except that in the process, you swap the negative to being for the C and the B in the second portion. So this carries on into the quadratic functions that we have. The standard form is f of x equals a times x minus h, which is squared, plus k. So in this standard form, we are working with the quadratic functions, and these are normally done with a parabola. So when you have a parabola, you would determine whether the parabola opens upward or downward. You determine the vertex of the parabola. The vertex is usually determined by the point h and k from the standard form for the equation there. And you find any x-intercepts, you put f of x equals 0, and then you would find any y-intercepts by putting 0 in the f of x function. Then you plot the intercepts and the vertex that you find, along with any additional points that may be helpful. Okay, so I was talking about the parabola. This is a common parabola here. As you can see, it's marked off with the x-intercepts, the y-intercept, and the vertex. So as we can see, it's opening upwards, and that the x-intercepts are where the graph passes through the x-axis. Here it is at -1 and 3. And for the y-intercept, it is passing through the y-axis, and that is at -3. So with parabolas, they also have a maximum and minimum value. And as you can see from the picture, it shows where it would be the maximum at the highest point on a parabola facing downward. And this is if your a is less than 0. And for the one on the right, for the max minimum, that would be where it is at the lowest point in the parabola. And that one is one that is facing upward. Okay, so we go into polynomial functions and graphs. I have a picture here that shows the graphs of some polynomial functions. So as you can see, they do have a way of determining how the polynomial functions work. So on to the left of the graphs that we have, it is an odd degree and positive leading coefficient. So if it were to show that it has one of the lines going down and up on the other, and with an odd degree with a negative leading coefficient, you can see that the graph begins upward and then begins to go downward. So with odd functions, you can see that the parabola has their ends going in different directions. They're not both facing down or both facing up. They're both in odds with each other. So that's one way to remember, if it's odd, that their ends are at odds. Even degree with a positive leading coefficient will show that the parabola is facing upward and in the same direction, as you can see with the next graph. With the last graph, it's a even degree number and a negative leading coefficient. So that goes into dividing into polynomials. Okay, so I will work with the parabolas for a bit, and I will show how they work in a function. So I have here is a graph with the Desmonds. It'll show the examples that I have here. So if we take the example of x minus 3 Okay, so this is a parabola that I have for the example. We have negative 2 times x minus 3 squared plus 8. So as you can see that with a negative coefficient, that is negative 2, that we're going to have our parabola facing downward. And that x minus 3 squared gives us an even degree, which is the 2 squared. And the 8 moves it 8 spaces up. So what I like about this is it gives us our points. As you can see, we have a y-intercept here at 0, minus 10, an x-intercept at 1, 0, and another x-intercept at 5, 0. And our maximum is here at 3, 8. So now if we were to make the 2 positive, it'll change our graph for us. Okay, so as you can see, once we have a positive coefficient, which is positive 2, it changes the direction of our parabola. Instead of it facing downward, it is now facing upward in blue. So that's what happens when you have a positive coefficient and if you have a even degree number here. So as before, it was facing downward and we had a maximum, which is the height of it at 3.8, but because of our change in coefficient being positive, it gives us a minimum now, as you can see for our graph in blue. And this is one of the ways that the parabola works. So what we do is we begin to work with the problem to see how it works. So as I was saying before, you would need to find the points that work on your parabola. So determine how the parabola opens. So we would look back at our standard form of our quadratic function, which is a times x minus h, the square root to the second power plus k. So now that we have our function, we would look at the main points, which is a, our coefficient, which is negative 2. And we would look at h, which is our negative 3. 3. And then we have our k, which is 8 here. So if we were to look for the vertex, all we would have to do is look at h and k. So that would be 3 and 8. And that gives us our vertex of 3, 8. Now, to find the x-intercepts, I told you you would have to set the equation equal to 0. So if we were to put 0 in for, if we were to solve for 0, we would get 5 here 5, 0, and 1, 0. And we would find our y by setting the finding f of 0, and that would give us this here, 0 minus 10. Okay, so let's try another. So let's try 3 x minus 2 to a odd 3 plus 2. So as you can see, our parabola changed quite differently. So in comparison, we have the first one, which is an even number degree, which is a square of 2. And in green, we have our odd degree, which is the power of 3. So each end is in opposite directions. So as you can see, we have it being open on odd ends, and it's working to the same extent that we had before. So now if you were to change the coefficient to being a negative, it is in an opposite. So it's pointing up and it goes downwards. And our vertex is still the same here at 2, 2. So that's how changing the coefficients. But let's go back and let's see how it changes for each degree. We can continue on with these. So we have, so if it is an even number degree of a square 2, it points upwards in green. An odd number of 3, both ends are the odd ends. Okay, now I added in the degree of 4. It's still following the steps of the second square, but it's a little bit narrower now in black. So it's still pointing upwards, and it still follows the same pointing upward for us, and the vertex is still the same at 2, 2. So as we look at it, it still follows this general rules that we were using to find it. Okay, now everyone believes that it still follows the same. So if we do x minus 1, x plus 2. So this is working in the same way as we have before, but this time we have x minus 1 and x plus 2. This shows us the graph in red of how it adjusts to it. So if you're having trouble with parabolas, best way to do it is by hand. And if you're not too sure, the best thing to do is to check with a graphing calculator. If not, you can also use a graphing website. So this is why I use this website, Desmos, to help me share and show how the graphs would look if you were to change them from negative to positive with the leading coefficient, or if you use a different degree in the process. So, as you can see, we have a falling and a rising parabola here because we have a odd degree with a positive leading coefficient. But we can change that with a negative, and we have a rising to a falling graph, and that shows here. As you can see, the graph is beginning to rise and then it begins to fall. And the same can be said with even numbers. So let's try a different one. We do square 2, and it's pointing upwards with the leading coefficient being positive. And if we do negative, it switches and it changes downward. Okay, so I'm going to go back to our last point, which is dividing polynomials. So for the example, I have 3 times x to the third power plus 4x squared minus 5. Supposed to be 5x, I'm sorry, plus 5 divided by 3x. So I shall show you how to do that with the whiteboard. I'll rewrite it out correctly. So we have x minus 3. That is going to be divided into x to the third power plus 4 x squared minus 5x plus 5. All right, so now that we have this, we're going to be doing a bit of division by the by x minus 3. So what we're going to be doing is we're going to be dividing it. What we do is we look at the first point, which is going to be the x. So we look at the x here, and we look at the first one here. So we know that x can go into x to the third power by multiplying it by x squared. All right, now we're going to be multiplying x squared to x minus 3. So we take the first one, x squared times x gives us x to the third power. We carry that over to the 3, and remember that we have a minus sign, so that's going to be carried over here. So x squared times 3, so we get 3x squared. All right, then we do our subtraction here. So the 3x squared, x to the third powers are canceled out. We go over to the next portion. So we have this here. This becomes positive here, and this is 7x squared. And then we carry on like we did before of normal division. So this is positive, so we have positive 7. That's the coefficient that we have. To make x squared, we need to times x by 7x. And then we multiply the whole thing again. So 7 times x, we get 7x squared. 7x times 3. So 7 times 3 is 21. We carry over the x. All right. Now we drag down negative 5x here. All right, so again, the first ones are canceled out. This is subtracted, so it's canceled. This becomes positive again. So we have minus 5 plus 21 which gives us 16. Okay, we have x here. It's carried down. All right, now we have 16 again here, so we carry it up here as our coefficient. Now it's positive. Since we don't need to add in an x because we already have x up here on the left from the x minus 3. We're going to multiply 16 times the term here. So we have 16x and then 16 times 3, we get negative 48. Again, we carry down the 5. Since it's positive, we add 5 here. And we do our subtraction. 16x is canceled out here, and we have addition to do here. So positive 5 plus 48 is equal to 53. Okay, now, since we cannot divide x into the number here, this is our remainder. And what we do with our remainder is we carry it up to the top and write it over our x minus 3 here. So we have 53 over x minus 3. So this is how you would do the division for the polynomial. Now, I'm going to do the synthetic division off to the right side to give an example of how it would look in comparison. So we have our remainder here and we have everything there. So all we're going to be doing is be arranging it by the coefficients. So I will mark the coefficients with the color pink. So our first coefficient is 3. The next coefficient is next to x cubed. Since that is here, it would be 1. So we write a 1. Off to the side here, we have x squared. The coefficient is 4. Our next coefficient is by x, which is negative 5. So we write negative 5. The last that we have is positive 5. All right, so what we're going to begin with is we're going to bring down 1. So that's our leading coefficient. So we're going to work off of that, and we're going to have 1 carried down. So it carries down here, and we're going to work off of it. So what we're going to do is we're going to multiply by 3 to this 1 here, and that's going to come up here as so. Let me change this. So the first one we carry down to 1. And then what we're going to do is we're going to multiply the 1 by 3. We carry it over and it becomes 3 here. And it's under the 4. Now, what we're going to do is we're going to add the 4 and the 3, which gives us 7. All right. Now, same thing again here. What we're going to be doing is we're going to be multiplying by 3 and 7. And then it's going to be carried up to here again. So 3 times 7 is 21. It's positive. So 21 plus -5 would give you a positive 16. So that comes down here. Again, we have our $16, which we're going to multiply by 3. And that's going to come up to here under the last number of 5. So 3 times 16 again is going to be 48. All right. Now again, we're going to be adding so now we have 48 plus 5, which gives us 53. Okay, so now we have our long division off to the left, and then we have our synthetic. So this gives us our coefficients for our division problem. So we take 1, which is going to be 1x squared. Let's write this. We'll write down the coefficients first. So we have 1, 7, 16, and 53. And I will write our x squared this is positive, so it's plus 7x plus 16 plus 53, and this is our remainder of x minus 3. So as you can see, we use both problems to get the same answer here and here. And that is the end of my workshop. Does anybody have any questions?